Hi, I'm Sanal Varghese, Product Marketing Engineer at Microchip Technology in the 16-bit microcontroller division. In today's world, technology is changing rapidly, and your product must be designed to be competitive during its complete life cycle to minimize design time for rapid time to market, future-proof your product by enabling upgrades and extend its life, and reduce product recall risks with the ability to fix issues remotely. Implementing a bootloader in your embedded design can help you with future-proofing and risk reduction, but it often increases design time. Some of the challenges in implementing a bootloader include increased complexity, ensuring a modular design in order to reuse the bootloader across multiple designs, keeping the bootloader simple to ensure that it can easily integrate with any of your end applications, as well as ensuring robust self-preservation and reliable operation. To help you reduce your design time, future-proof your product, and reduce your risks, Microchip offers you the 16-bit bootloader supporting 16-bit PIC24 MCUs and dsPIC33 DSCs as a part of MPLAB Code Configurator, or MCC. Using the intuitive MCC GUI interface, you can add bootloader to suit your application needs. For developers, Microchip also provides application firmware configuration to customize the bootloader with the application easily. MCC Bootloader also takes care of your security requirements by optionally allowing the application image to be verified for its authenticity using advanced cryptographic algorithms before updating it. To complement the bootloader library in MCC, Microchip provides a unified bootloader host application. This tool can be used to transfer new application code to a PIC24 MCU or a dsPIC33 DSC that contains the bootloader code. Now, let's go through a quick demo on how to implement the bootloader in your application using MPLAB Code Configurator. For this demo, we will be using the PIC Wireless Google Development Board, and we'll be writing a bootloader code for the PIC24 FJ128GA705 low-power MCU. As you can see, the board is already running a code blinking the blue LED. Our demo goal is to write a bootloader code and update the application image to blink a different LED. But before we get started, please make sure you have the latest version of MPLAB XIDE, XC16 compiler, and MCC to program the PIC24 FMCU with a firmware to blink the blue LED. First, let's create a new standalone project. Select your device as PIC24 FJ128GA705. After connecting your PIC Wireless Google Development Board, select the same under the tool. Then select the XC16 compiler. Now, name your project and launch the MCC. Using the pin manager, let's configure RC5 as a GPIO output pin, which is connected to the blue LED on the board to blink it. With the rest of the standard device configurations in place, generate the code automatically using the MCC. Once you program this code into your board, you will see the blue LED blinking. Now let's create a bootloader for this application. Create a new project and name it boot. In bootloader code, let us blink the yellow LED by configuring RC3 as an output pin and RA7 as an input pin. The next step is to create the bootloader functionality, for which we need to select the 16-bit bootloader under Library Resources. Select a communication peripheral, and in this example, select UART1 and configure it as per the requirements. And now you're all set to generate your boot code. Once generated, you can edit the main source file to blink the yellow LED while the bootloader is getting executed. Once you download the generated code into the board, you will see that the yellow LED starts blinking, indicating bootloader execution. In a practical scenario, you would want your bootloader to load the application into the memory. Now let us reconfigure our application so that the bootloader can now load this application into the memory. This tedious process of linking the application to the bootloader gets extremely simplified with the help of MCC. You just need to go to the app project and select the application bootloader library. This will enable you to load all the configurations of the bootloader into your application. Just select your bootloader project. It will show you all the necessary configurations like bootloader address, application address range, and the interrupt table mapping address. As you proceed, the actual application is now linked with the bootloader, redoing the memory mapping. Let's compile the code now. Once compiled, you will get the hex file, which can be loaded onto the board with the help of the Unified Bootloader Host Application tool. This tool can be downloaded from the Microchip website. Just select the device architecture as PIC24/dsPIC33 MCUs. Load the application project with the hex file you just generated. Then select the serial port and update the address of the board. Now all you need to do is program the board. On successful boot loading, as you can observe, the new firmware on the device is now blinking the blue LED, indicating a successful firmware update. So, in just a few simple steps, MCC allows you to add bootloader into your application, significantly reducing your design risks and your development time. To learn more, visit microchip.com/16-bit bootloader and download the library with the associated documentation. Thanks for watching.